With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us solve this question. The question says that statement 1, coordination isomerism occurs when both the cations and anions are complexes, and statement 2, oxidation state of central metal ion in both coordination spheres is always equal. Option A, statement 1 is true, statement 2 is true, statement 2 is a correct explanation for statement 1. Then option B, statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1. Option C, statement 1 is true, statement 2 is false, and option D, statement 1 is false, statement 2 is true. So in this question, two statements are given, statement 1 and statement 2. We have to check whether these statements are true or false. So in first statement, it is given that coordination isomerism occurs when both the cations and anions are complexes. So this is absolutely true. Now let us see what will be there in coordination isomerism. So let us take a coordination compound in which we have both cation and anions are complexes. So we have CO, NH3, 6, Cr, CN6. Now in this compound we have both cation and anion, that are the complexes here. Now CONH36, this is the cation, and CrCN6, this is the anion. So in this basically coordination complex, we have two coordination sphere. In first coordination sphere there will be 3 positive charge, and in second coordination sphere there will be 3 negative charge, right? So first is cation and second is anion. Now if you calculate here the oxidation state of cobalt in this complex, now NH3 is neutral ligand, so cobalt is present in +3 oxidation state. Then we have here chromium. Cyanide is anionic ligand, it has -1 charge. So when we calculate the oxidation state of chromium, it will be equal to +3. Right. Now basically what happens in coordination isomerism, there is exchange of ligands between these two coordination complexes. Right. So what happens, there will be exchange of ligands between the two coordination spheres. Now what happens when there will be exchange of ligands? So we get chromium. Now with chromium there will be NH3, 6 times, and with cobalt there will be CN6, CN6. Now basically composition is same. Now what happens, the coordination sphere CrNH36, it will be having now 3 positive charge, and COCN6, it will be having 3 negative charge. And when we calculate the oxidation state of central metal, chromium will be having +3 and cobalt will be having +3. So basically what happens when there is exchange of ligands, the oxidation state of central metal does not change. As you can see here, the oxidation state of chromium and cobalt does not change, right? So this is coordination isomerism. So it means the first statement, coordination isomerism, occurs when both cations and anions are complexes. This is true, right? Because the in anionic and cationic complexes there is exchange of ligands which take place in coordination isomerism. Then in second statement given, oxidation state of central metal ion in both coordination spheres is always equal. Now this is false. It is not important that there should be equal oxidation state of the central metal ion on both the coordination spheres. Now the example which we have taken, in this example we have equal, but there are many other examples, right? For example, we have CO NH3 5 NO2 Cu CuCl4, right? So basically this is a coordination complex in which we have two coordination spheres. First one is cationic, second one is anionic. Now in the first coordination sphere, that is cation, we have two positive charge, and in anion we have two negative charge, right? So when we calculate the oxidation state of the central metal in the cationic coordination sphere, the oxidation state of cobalt will be +3. When you will calculate, you get +3 because NH3 is neutral but NO2 is anionic ligand having -1 charge. Then in CuCl4 2 negative, the oxidation state of comes out to be +2 because here chlorine is having -1 charge, right? So as you can see in this, both the cobalt and copper have different oxidation state. So when there will be exchange of ligand, so what can be done? Here the NO2 and Cl, these can exchange their position. So we get another coordination compound CONH3 5 Cl CuCl3 NO2, right? Now in this coordination complex there is exchange of ligand NO2 and Cl, right? But if you calculate the oxidation state of cobalt and copper, that will be same, right? Here cobalt will be having +3 oxidation state and copper will be having +2 oxidation state, right? So from here we can say that the second statement is false. So from these observations, the correct option will be option C. Statement 1 is true, statement 2 is false. So this will be the correct option. So option C is the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.